I'm speaking on behalf of Mountain Disaster Preparedness. I've never seen a crowd like this where we're not serving alcohol.
It's true. Where's the wine?
We came up with this idea about 3 weeks ago when we had a MEMSCOM meeting in this very room. And I want to, Kat Henderson, thank you very much for helping arrange this. Thank you very much. MEMSCOM, what does it stand for?
Hold it closer.
Communications Committee.
That's it. Anyway, it looks like we struck a nerve. We are so well, let me start over. Mountain Disaster Preparedness that's our role, is to prepare and encourage you folks to prepare. Obviously fire, obviously earthquake, where we've got our DAS units throughout town to support our CERT teams. But there's also another issue, and that's weather. And that's what we're talking about here tonight. We are so desperate for rain, and the reports coming in from NOAA indicates we've got something brewing, but the news media has taken off with it, and the word Godzilla has been used. And entertainment value and ratings on ABC, NBC, CBS are all the same. So we wanted to talk in specifics tonight from a professional that could give us an idea in comparison to 97. How many were here in 97, 98? What was it like?
I was in Pine Cove. I had a 5-foot fence, and the snow was over it.
Oh yeah, I was there. Over Strawberry Creek was rapids.
Okay.
Whitewater.
So, I mean, if we're looking at a comparison and no two El Niños are alike, and we've got an event going on off Alaska that could change things, but preparedness is the name of our game. We're going to present the forecast in the beginning part of the program, and then we've got two locals that are professionals in regard to erosion, structure control, mining, what water we do get. So at around 7 o'clock, I'm going to bring on the Geisingers, and we'll talk about some tips in regard to what we're looking at this year. But that's it for MVP. I want to introduce our guest speaker. He came all the way up from San Diego. Many of you know of him from the alerts that are sent out for flash flood warnings and the like. Alex Tardy, I'm going to read your title. It's 2 lines long. A man of many hats. It's Manager, Warning Coordinator, Meteorologist, National Weather Service. So with that, can everybody hear? We've got them.
Your mic isn't loud enough.
Keep it close? Does that help?
Yeah.
Okay, we can turn that volume up, but I don't want to disturb the rest of the library. Before I get into that, we are pushing the top limit of the population of the library. So I've been told emergency exits, 1 there, 1 here, and out that side door and out the front. And I've also been asked to leave a pathway for people that have to leave or want to get out, to let them through. And with that, Alex is going to present. We'll do a short Q&A for him right after his presentation. Then the Geisingers will do theirs, and then we'll have a longer Q&A at the end. Okay? Here we go. Alex.
Thank you.
Thank you, Mike, and welcome everyone. Can we hear in the back pretty good? All right. My voice tends to project pretty well. This is amazing here. So Idyllwild needs a bigger library. That's an action item, or a bigger center to talk. But this is a great turnout that you guys are taking it so serious, and so many of you are coming out here to learn about El Nino, about preparation, about what you can do. And bottom line is getting educated and making wise choices for your community to help out everyone. We're going to talk mostly about El Nino and the El Nino phenomenon, what's it about. I work for the National Weather Service, as Mike said. It's about about 2-hour drive to Rancho Bernardo. It's not too bad. I took the 79, 371, pretty quiet road, not much traffic on it. I've taken the 215 and other ways, but this seems to be the best way coming up. If you're ever in the area, Rancho Bernardo, off of I-15, stop by our office. We're a 24/7 operation. There's always meteorologists working. The door is locked since it's a federal facility, but let us know, give us a call, knock on the door or something like that, and we can help you out. And for those of you who didn't get cloud charts especially, you can come by and grab a cloud chart. I promise you we'll have some there. I did not expect this many people. I mean, to be honest, I do a lot of these talks. I thought 35 maybe. So what do we have in here? Like 150? So where's that sign that says maximum occupancy? So we don't worry about that. Is the fire chief here? Good, he's not here. All right. He's probably not far away, though. I'll probably get an email from him or a phone call. Like when he calls me and asks, how much snow is going to fall in downtown Idyllwild? No, I want downtown Idyllwild. I don't want Pine Cove. I don't want... Okay, we'll do our best. So with El Nino, like Mike said, the media's really gotten a hold of it. It's good and bad. Weather is big news across not just the United States, not just California, but really the whole world. And weather's getting a lot of headlines because of the extremes and the damage and the cost and the economic impact and the effects of lives and property. And that's really the mission of the National Weather Service, to try to reduce that. We can't stop it. We don't make the weather. We don't stop the weather. We wish we could, especially when we were younger or if we miss a forecast. But it's just getting a lot of attention. The NBC station announced that they want all their TV casters to actually have a degree in meteorology. They're getting more time on the air. Computer models are getting sophisticated. The tools they're using to present to you and me are getting more sophisticated. So we got a new satellite we're launching next year, geostationary satellite. We have a lot of information that's coming down, and weather is definitely improving, but we've got a long ways to go before it's anywhere from perfect. We're going to talk about El Nino, and a lot of times El Nino gets thought of as rain, floods, that type of thing, but El Nino is actually, all it really is sea surface temperatures in the equatorial Pacific Ocean, way out south of Hawaii, where you're seeing a lot of hurricanes right now. No coincidence. The hurricanes are feeding off of the warm sea surface temperatures in that region. During the summer, El Nino really doesn't do anything other than feeding the tropics. It actually hurts the tropics in the Atlantic. We're not going to go into all the details why. But come winter, when those warm sea surface temperatures, so we're talking only a few degrees. You might notice on an average day the temperature might be 5 degrees warmer. You might not even notice it's warmer. But in the ocean, when the temperature is 5 degrees warmer Fahrenheit, it's a big deal. And especially when you're talking about winter. In the winter time, when our normal jet stream drops across California from the north, it usually likes to hang out around Oregon, Northern California. When you have the warm sea surface temperatures in the equatorial Pacific Ocean, the two contrast. And that basically what you're doing is changing the climate just for that winter. But you're changing it for several months. So what El Nino ends up being is a change in the position of the jet stream. And that jet stream is what brings our storms. Not the storms we see in the summer, not the monsoon thunderstorms, but the big storms that come off the Pacific. And it changes the track. So we end up getting more storms, and typically a lot more storms in a strong El Nino. Not necessarily bigger storms and historic storms, but when you get more storms and they repeat, you have less time to recover, more impact, more erosion, more chance of landslide, and so forth, bigger snowpack like we talked about before. All right, so let's get into it, and there will be time for questions. I just took this image off the internet yesterday. NASA JPL is they're creating a new tool. Basically, NASA and NOAA, my parent organization, National Oceanic Atmospheric Administration. So I work for NOAA. Yes, even though it's kind of funny. A lot of times I'll go give talks and someone will say, well, someone from NOAA was here. I'm like, who? and they're like, I don't know. Like, was it National Weather Service? Oh, yeah, I think it was National Weather Service. Maybe it was NOAA, but it's the same thing. NOAA is a big organization. It has other agencies in it, ocean services. It's not just weather, but it has other ones. All right, so on this screen here, your eyes are probably drawn to a few things. Oh, it doesn't work on the TV. Interesting. What's up with that? You guys have too modern of a TV or something. It absorbs. It's El Niño, yeah. It's El Niño. All right, well, we'll resort to just the finger and pointing. Okay. So this is the Pacific Ocean. You can kind of make out where California is. Where California is, it isn't that important, but so the El Niño area is down across the bottom. The bright red, orange, purplish colors there, whatever it is, depending on your eyesight. Then there's one in the middle, as well, and then there's another area, and they're not all El Niño. And so the media's got a hold of a couple of them. El Niño typically is the center of attention. But now we have blob, and we have blob number 2, and we have the El Niño region. The region we're going to focus on is the El Niño region because that's the region that we scientifically show a lot of correlation to really changing our storm track. The other ones, and we'll go into a little detail here of how the other ones were formed. All right, right here, and I myself, I could look at something like this for hours and probably find something new and go cross-eyed. So forth, but this will play. This is about a 5-year animation of sea surface temperatures. And what I want to show you is in the North Pacific and then in the El Niño region, the rectangle, and the oval's North Pacific. Focus on those areas, and we'll go through this in just a couple minutes here. Notice that there's been a lot of warm water. The bright colors are the warm water, and a lot of warm water in the North Pacific. Notice how it's been slowly moving from west to east, sloshing back and forth, and then just in the past year, now we're going on 2014, it started to shift further east. And it was actually moving around and expanding, and there well before El Niño was even present. Now the El Niño region, which is in the rectangle, as we're looking at here, didn't really get going until right there, until late this spring, about May, July, and then most recently in August. Now, the point is that the region in the North Pacific with all that warm water, in our past big El Niños, we didn't have that. And so there's a little bit of unknown of what's going on here. Some believe it's overall global warming. When your oceans start to warm, it's a strong indication that the atmosphere is too hot. Oceans are very sensitive. They have a big heat capacity. They're hard to warm up, hard to cool down. And probably no coincidence that in 2014, globally, even in California, was the warmest year on record for land. And it also was the warmest year on record for ocean temperatures globally. So what we think happened is in the North Pacific, because we've had really no storms here in California, the storm track's been so far away, and we'll show some maps on that in a minute here, that has actually caused all the warming in the North Pacific, not the other way around. Not that the warm water caused the lack of storms, that the lack of storms is causing all this warm water to move from west to east, from areas where it's normally much warmer, the Western Pacific, and move across. Of course, this is all relative to normal. So when you see bright colors, it's much warmer than it should be. It's not a bathtub. If you jump into the North Pacific where you see those bright reds right there, I'm not going to guarantee you're going to enjoy the water. It's still going to be cold, but it's relative to what it should be. This uses satellite data mostly. It also uses buoy data, so like instruments in the water as well. All right, so that region in the equator, what we call El Niño region, is what we focus on. That region basically does what it's doing now, but it doesn't develop hurricanes in the winter. It generates moisture, and moisture like boiling water on your stove. And that in itself interacts with our normal jet stream, which is basically cold air to the north coming down. The two combine and you get an enhanced, consolidated jet stream focused not every single day, but focused in general over the winter over central and southern California. All right. Mike mentioned this, very good, Mike. I don't know if it was planned, but he said not all El Niños are the same. And that's very important when it comes to the science of El Niño and then the impacts of El Niño. So we have had El Niños, believe it or not, that have started drought in California. 1976 was an El Niño. 2006, 2007 was an El Niño. We have had historic flood events in California, and those were non-El Niño. Non-El Niño. January 1997, January 1993, those are 2 years that were not El Niños. But, on the other hand, some of the big El Niños we've had, like 97, 98, 82, 83, 72, 73, those big ones really delivered across the state and really advanced the science. So not only does the shape of El Niño look different, here's 1997, 98, right here, this bright red. Not only does the shape different, but the configuration and then most importantly the impact, where it brings rain. So imagine when you have this massive jet stream, okay, and it's like shooting darts. So if the jet stream focuses on central California, Southern California misses out a little bit. We're on the edge. If it focuses on just Southern California, Northern California really misses out. And you can kind of do the math. It cannot cover the whole entire west of the United States because it's just too big. But an ideal situation is that you have a jet stream that is waffling up and down across California like your sprinklers. So you evenly spread the water out across the whole state and hose it down. That would be ideal. All right, here's some numbers for you. Don't focus too much on the numbers. The ones in the yellow are different El Niños, and those are the strength of them. And you can see our big winners were 72, 73, 82, 83, and then 97, 98. Those are kind of the big boys, if you will. And on the next column to the right is what we talk about is how much rain actually fell. This is using a location in San Diego. We'll talk about specifically in Idyllwild in a minute. And what we found is in the strong El Niños, there's definitely a big correlation. In the weak to moderate El Niños, not much correlation. At least nothing you can really hang your hat on. All right, before we get too far ahead of ourselves, the drought. So we have to talk about the drought because it's quite possible, in a nutshell, that we'll be talking about drought in California, and the media is going to love this, but drought in California while we're talking about massive flooding at the same time. And it's quite possible that when we get into the spring, we're still talking about severe drought in Northern California. And what happens in Northern California does affect us down here, including the Colorado Basin. And we might be talking about extremely saturated conditions in Southern California, and we won't want any more rain, but yet we're still in a drought. So this drought is taking on its own thing. I don't know, why did the drought get a name? I mean, El Niño gets a name. I mean, the drought is actually more impressive and has been around a lot longer and probably has greater impact, at least statewide. Anyway, so the drought's been on for about 4 years now, and it's the worst drought statewide that we've ever seen in 4 consecutive years. What happened? Well, it really started 4 years ago, but back in 2013 and 2014, when you look at the storm track that we just talked about, it was non-existent. The storm track went up and over all of California and then dove across the Great Lakes region. And it wasn't like 1 week. It was months where we could not buy a storm. And we ended the season statewide with 40, 50% of normal. And that's snowpack. Snowpack was 25%. Then you flash forward to just this past winter, and I have not met a meteorologist or climatologist that expected the Sierra Nevada to have 5% snowpack as of April 1st when they take their core samples. The year before it was 25%. 1977 was 25%. 5% of normal. So what happened? Well, the atmosphere never reset. The same ridge of high pressure, just think of it as a dome of warm air, and it forces the jet stream, big rock in the river, forces the jet stream to go up and around it, was in place and actually shifted further east, so it was actually right on top of us. No coincidence that the ocean temperatures warmed, no coincidence that we temperatures, we were extremely warm in 2014. If you guys remember March of this spring even, it was record-breaking warm everywhere. Coast, mountains, it was just off the chart. So we're seeing a lot of extreme weather.
No fog in May.
And yeah, exactly. All right, so over the past 12 months, we have seen temperatures across Southern California just going up and up and up, up and up and up. And when you look at 48 months of precipitation across the whole entire state of California, mountains, average in the deserts, Eureka where it rains all the time, San Diego where it never rains, we look at the numbers and the state's missing 27 inches of precipitation statewide. That's over 2 feet of precipitation in 4 years. Just an incredible amount of precipitation. And we've not seen a time this dry. The next time that's closest, 1927 to 31. Next time closest. All right, this animation here is a depiction of what are we missing. So when you see the bright colors on the right, and there's the animation on the left, the deep reds are the ones where we are missing almost 2 seasons, in some cases a little more than 2 seasons, so anywhere from 1.5 to 2.5 seasons of precipitation out of only 4 years. So basically 2 for 4. It's as if we had 2 winters missing, like they just didn't happen. And when you bank all your precipitation, most of the state, on your winter season, your rain season, you cannot be doing that. And no wonder we're in the drought that we're in now and in the high fire danger. Here's some numbers for those of you who don't like graphs or charts and pretty maps. You just want numbers. Let's take a look at Idyllwild. Okay? We have some really good climate records. It's one of the hardest things is not forecasting the weather. It's keeping track of climate information. Most people, most agencies, most post offices, whatever, they don't want to take weather reports every single day at the same time, 365 days of the year. But those same people are wondering, how come you don't have any records for my town? So, Idyllwild, we're lucky that we have some very good records, but they don't show us good information. Here's what I mean. So in the past 4 years, Idyllwild has had 78 inches of precipitation. So that's snow and rain melted down. The deficit, 41 inches. 41 inches. What do we need by next year to get back to even? To just make up for those lost years? Because that's usually what the weather does, right? It makes up for what we didn't have and we get too much of a good thing. We need 67 inches. And the average in Idyllwild is about 26. That's why we have some nice big trees out there. 26 is actually not bad for Southern California. But the chances, historically, for us to do that is 0. And we don't usually say 0 in meteorology too often, or 100. So the bottom line is we have really dug ourselves, not just in Idyllwild, but statewide, coast, mountains, valleys, deserts, into a situation of precipitation deficit. All right, so let's focus more on the good news, or at least on El Niño, what we think is good news in some cases. Historically, El Niño has delivered 82, 83, 97, 98 were really wet years statewide. Really wet. A lot of impact. And in some cases, a lot of damage and some costly damage. However, some of the other El Niños we have, and media doesn't like to talk about this because it doesn't make a good story, they've been really a mixed bag. They've been dry in Northern California. They've been mixed, wet in Northern California, dry across the whole state. It's really been a mixed bag. But the 2 big ones that we can compare to, at least what El Niño is expected to be this year, were very wet. And we'll show some more charts on that. So in order to get out to stop talking about this annoying drought, statewide we'd need about 150% of normal. So that's your season and a half. Statewide. You'd also need a snowpack. If you notice the snowpack in California specifically over the past couple of years, anyone here work or operate at Big Bear or any of the ski resorts? Well, last year you could not even make snow. There was about 10 days where it was cold enough at night where they can make snow. The air has been so warm. So it's bad enough that it doesn't snow, but then it's bad when the air is really warm. Well, we would need snowpack and above normal snowpack, significantly above normal. Past El Niños have been variable, like I talked about. For Southern California, there's a very good correlation with these bigger, stronger El Niños to the heavy rainfall and the heavier snow. It is important to keep in mind, though, that it doesn't necessarily mean the biggest storms ever. So it would be incorrect to say the biggest storms occur in El Niño years. It would be correct to say in most strong El Niño years, we get a lot of storms. We get more at-bats, more frequency. We need that snowpack to stop talking about drought. So, strong El Niño on the left-hand side here. There's only been a few of them, 6 actually. You can count them almost on a hand. Hopefully, you can't count them on one hand, unless it's a cat or something. So, the El Niño tends to go across central California, down into Texas, and then out into southeast. And literally what you do is you change the jet stream for the course of the several months, especially between December and March of the middle of the winter. However, when you remove the big El Niños, when you remove the big ones, 82, 83, 97, 98, the blues start going away. They shrink. They remain over Southern California, Texas. So basically what that tells you is the signal decreases. Look at the Pacific Northwest, where it's already a lot of problems. Burning, drought. And they're just in the start of their drought, really, the past year. In an El Niño, they tend to be not just dry, but very dry. So not looking good, at least historically, when you look at other events. All right. Over the past 2 years, this is what the jet stream has been doing. Maybe we... I don't know, didn't pay our taxes, maybe we're not being good citizens in California, maybe it's a strong signal we need to stop using so much water. The jet stream has missed us, basically. And when you average 2 seasons together and get a signal like that, that's not good. And it's no surprise that the result has been no rain. Now with our strong El Niños, it's almost like that's our Christmas present. It's direct hit. It comes right at us. Right at us. If we had El Niño every year, I don't know, it would probably be a tropical rainforest, I would think. It would be pretty incredible. So on the right, El Niño. On the left is our past 2 years. And it's really important because when you start talking about preparations and impacts of El Niño, some of you here that are local probably have very good memories. Others, you may not remember what the weather did last week. And when we're in the midst of a drought, and that's all our recent memory is dry, this creek never runs, I don't know why this is like that, or why do I need to clean this brush over here, it's not going to run. That's where it becomes important to put into context that we have not been in a situation potentially like this for a long time. All right, when you look at departure from normal, this gets a little scientific, but if you look at warm as the red and purple as cold, on the left-hand side is an average of the past 2 years. This is not necessarily temperature at the top of Idyllwild. This is the temperature if you were flying an aircraft in the atmosphere. So it's really important to look at the upper part of the atmosphere. Very red, bright red. Basically because we've had no storm systems coming through California other than, 3 or 4. On the right-hand side is what strong El Niños have done. You can see how it's complete flip 180-degree opposite. Also notice on the left-hand side, look at the contrast between the cold air in eastern Canada and the warm air over northern California. Well, that is where your jet stream was. And that's why Boston and those places have record snowfall, because the pattern was just locked in. And this is 2 years in a row where the pattern was locked in, missing California and basically going across the mid-Atlantic state. So El Niño on the right. And the other thing about El Niño, that the misconception is, it's not the Pineapple Express. Why does the media use that? Because it sounds good. Oh, we're getting rain from Hawaii. Watch out, it's tropical. So a tropical hurricane, winter storm, or something like that. It's not the Pineapple Express. But what it is it's the Pacific Express. And it's storm after storm after storm coming in off the Pacific. Okay, on the left-hand side, when we get back into sea surface temperatures here, like I showed you earlier, on the left-hand side is the past 2 years. And so it's an average. Notice that the blob was already there well before El Niño developed. On the right-hand side is what El Niño typically looks like. And when I said earlier that we have not seen an El Niño like this with so much warm water in the Pacific. This is what I meant. Typically is what we see on the right. The warm water goes to South America, squirts up to the Baja, and makes it up into California, and our beaches get a little warmer in some of the bigger El Niños. But our beaches, the Baja, and our Pacific was already warm, very warm, even before El Niño started showing itself. So we do have a different type of situation going on, and so that brings out a little bit of uncertainty. Is this going to be worse, or is this going to be a weaker type? And that just is a question that's not really known at the moment. So, what typically happens when you get a strong El Niño, and then there's been about 6 of them in the past, dating back to like the mid-50s, when we had satellites and other ways of really determining what was going on. We typically start seeing a little bit of impact in October over Northern California. We start getting an active storm. Not just because it's winter setting up, but it's just coincident because the El Niño and the jet stream are starting to work together. Usually it takes a couple months for them really to get going. In November, California tends to get wet, and then we have a little relax in December, and then January it starts to get wet again in blue, and then look what happens in February and March. So as soon as we think, okay, woo, we got through December and January, not too bad of a winter, hold your horses, hold the press, we are typically in these strong El Niños. It takes a while. Look what you're doing. You're basically changing the climate temporarily. And that usually takes thousands of years. But with El Niño, you're changing it over the course of one winter, so it takes a little time for that jet stream to respond. But once it does, it is really delivered into California in terms of heavy rain, mountain snow, and so forth. All right. So on the left-hand side is when you group all the El Niños together, whether they're big, little, tiny, super huge, Godzilla. Bruce Lee, did you hear the Bruce Lee one? Yeah. Someone asked me about Bruce Lee, and they said, wasn't he like a good guy? Didn't he like beat up bad guys? And I thought Godzilla was a bad guy.
Yeah, I thought so too.
So I don't know. It just sounded good, right? What happens when you do interviews with media? You don't slip things like, "Oh, this sucks," because then they're gonna quote that.
Head over there, right?
You see shaking?
Crashed.
Oh, it's recording too. Anyway, you don't want to get a habit of. Did you write that down?
He's writing down the sucks.
See what I mean? So when you say things like Godzilla, it's not necessarily their fault, you know. It's what they. You got to be careful what you're thinking. Anyway. On the left is all the El Niños, okay? There's a lot of blue in Southern California. That means, you know, there's a really good correlation to El Niño and wet winters. But look what happens in the right. When you remove those big El Niños, the ones we've had, Northern California, not only is it not average, it's much below normal. So if you have buddies, relatives, folks, scientists, whatever, might be living in Northern California, they might be telling you, what do you mean El Niño is going to be, you know, a lot of rain? Not so quick, because Northern California is still very worried, and because they're worried, we need to be worried a little bit in terms of long-term drought impacts. But Southern California, there's still a good signal. Okay, how about what have you done for me lately? We don't remember what happened last week, so how are we going to remember what happened 5 years ago? The last El Niño we had that was of any significance was 2009, 2010. We had a couple of big storms. There was one in January that was big. There was one in December 2010, the following year, that was big. But overall, the signal in California was just an average year. 30-year average, you know, flip of a coin. It was just a normal year. Our last really wet year was actually a La Niña. And this is where we get into the territory where, what are we looking at here? Are we looking at climate change, global warming, climate variability? Is it natural? What's going on? So we've had, even in the past 6 years, something that we really didn't see before. A huge wet season in all the West in a La Niña. So keep that in mind. Okay. The other bad news, especially for Northern California, is in the 60s they had a really strong El Niño. Not as strong as what we're expecting this year, but it was strong. And it started off really wet in Southern California. We had all of our rain in Southern California in November and December. And then it just stopped. We ended up average because of all that rainfall. Northern California, it never got going. It never got going. They ended up much below average. And that was a strong El Nino. However, and this is the favorite media slide because this is the one that fits the picture, you know, the data fits into the puzzle. The past 2 El Ninos, the big ones, the one we're expecting this year, across the whole state have been wet, and they have been above normal. And actually they've done really well in Northern California as well. So the benchmark El Ninos, the ones where we thought as scientists we had it pegged and we'd get every single El Nino, and then we had the one in 2000.